here we go with the Audi. I want to figure out why this cooling fan did not come on, and the car was obviously overheating, and the temperature gauge on the cluster stayed at cold. Again, everything with this car, there's just issues all over the place. Let's pull up a wiring diagram of the radiator fan circuit. It's not trivial. Again, it's a 3-stage, 3-speed fan controlled by a lot of different variables. And let's try to pinpoint, what is supposed to make this fan turn on. Is it capable of being turned on? What's going on with this thing? Alright, so I have some redrawn diagrams printed out. Now, all data, they don't have the main powertrain diagram in redrawn format, but for the cooling fans, this is actually very helpful. It speeds up the process, because if you go to the track style diagrams, you're going to spend at least an hour printing out 15 pages, and then tracing all the circuits through all the tracks is just very time consuming. And I did verify that these are indeed accurate. So this diagram right here is just for the radiator cooling fan, and then they also have an injector cooling fan, and then they have this turbo coolant pump. If you remember, when we first started on this car, when you turn the ignition key on, you could hear something under the hood. I thought it was a fuel pump. It wasn't. It was this. This is the auxiliary coolant pump for the turbo, right down here, and that kicked on, and I think the fan would come on, and we pulled the relay to to just disable that. But now the car starts and runs, but this turbo coolant pump doesn't work, the radiator fan doesn't work. So what changed? Let's look at the controls for the radiator cooling fan. So it's grounded on one side and has 3 inputs on the other side. So there's 2 wires coming from this radiator cooling fan 3rd stage. This is like high speed. So if we have hot at all times, we have constant power right here. If this relay closes, you got full speed fan. What causes that relay to close? Well, we have these radiator cooling fan thermo switches. It's a dual switch. And if you get power on this wire, if that switch closes right here, radiator fan should come on at full speed. The other wire comes from this dual resistor pack, and we have 2 inputs here. So let's trace this one. So if you're just going through one resistor, that's like medium speed fan. That comes from radiator cooling fan 2nd stage relay. What causes that relay to turn on? See, it's grounded on one side on the control. On the second side, either the AC or high pressure switch, if that closes, that relay should turn on. The air conditioning on this thing, the belt's off, so we're not worried about that. The second input to stage 2 is this other thermo switch on somewhere on the radiator. So this is basically as the coolant in the radiator heats up, first this one would trip to command the fan at medium speed. Then if it gets really hot, this other switch would trip and command it to full speed. Okay, that makes sense. Finally, for low speed fan operation, from this resistor comes from the 1st stage relay. And what triggers that relay to kick on? Well, let's see here. The control side, we have constant power on one side, so whenever this pin is grounded, you would get low speed fan. And that is triggered by this radiator cooling fan after run relay behind left kick panel. Okay, interesting. And then the air conditioning system could also kick this relay on for low speed fan. So if you look at the 2 other diagrams I printed out, this is for the AC HVAC circuit. I mean, it has the automatic air conditioning control unit, AC programmer, and this is that cooling fan after run control circuit that was on the other page too. Controls the turbo coolant pump, which is not kicking on anymore, and also the low speed fan through this brown and yellow wire. So if it grounds that, you should get stage 1, low speed fan. So where do we start? Well, these relays are easy to get to. They're right under the hood in that fuse relay box. So stage 1, stage 2, and stage 3 should all be hot on terminal 30. That's on the load side. So we could do easily is remove the relays and just jump 30 to 87 on each one of these relays and see if the fan is capable of spinning on low, medium, and high speeds. That'll at least rule out the load circuit, and then we can focus on the control side and the relays themselves. Alright, here's our fuse and relay box. And the relays themselves, let's see, relay number 2 is fan, engine, radiator, relay. Relay number 3 is cooling fan delay. That might be the low stage. And I don't see relay number 3. So again, the labels might be off or whatever, but all these relays should be hot on terminal 30 all the time. So I have the first relay popped out with relay number 2. Jumpers in here on the load side. So test light to ground. Okay, that terminal is indeed hot. What happens if we just jump these two? Will the fan come on? Okay, very nice. So I don't know if that was low speed or high speed, but that load side works. Let's move on to the next relay. Same thing here. Now the pins are turned around. So let's check with a test light which one of these is hot. Okay, that one is hot all the time. If we jump these two together, okay, that might be low speed. So compare this to this. That's definitely higher speed. So I think relay number 3, this cooling fan delay, that's the one, that's the low speed controlled by that whatever turbo coolant pump relay. Okay, very cool. Alright, so I found by visual inspection the radiator thermo switch is 3 wires. And I want to test this high speed circuit. So which wire do we energize? Looks like the green and violet on pin 1. If we put power to that with a test light, it doesn't take much to turn on a relay. This fan should kick on full blast. So here we go, test light from battery positive. It finds the ground. So we got 12 volts in the tip of the test light. I got a long piercing probe here on that pin number 1 because I couldn't get it otherwise. So I'm just going to touch the test light here. Let's see, test light's hot. Try it. That's definitely high speed. Now, where is that relay? Can we hear it click before the fan kicks on? Well, we do know that the relay works. Whoop. So, we just proved right there. On the load side, the fan can't come on in all 3 speeds. So the resistor is good, the fan, load side is good, the ground is good. We don't know if the Thermos switch is good because it never kicked on the fan. Now what feeds the Thermo switch? Blue and red, fuse 15, 25 amp, hot and run. So we have to check that. Let's check that right now. We just turn the key to run, go to fuse 15, put a test light on there. Well, there you go. That's definitely hot. The feed wire's good. We proved the high speed load side works. We can control the other two relays. I popped them back in. We can feed power to that third wire that's supposed to kick on the second stage, and then for the first stage, that's controlled by, you know, one of the two. Either this after run relay, which is turning on the turbo coolant pump now. So maybe when this first gets power, it's supposed to like ground this to make sure the coolant pump spins. I don't know if it's supposed to ground out this brown and yellow on the first stage relay, perhaps. We can put a test line in there, do that quick check. But for the second stage, if we feed power to here, it should turn on the second stage. Alright, here's stage 2 check. Test light from battery power. Alright, so we just proved the relays are good, load side circuits are all good, control side from the thermo switch is good. Thermo switch has power, so this thing overheats and the radiator's getting hot. The only problem it could be is the thermo switch. What are the chances that both medium and high speed circuits in that switch would fail? I don't know. It's an Audi, but at least the diagnosis is showing that so far all the components are good. So we still have to figure out what the real engine temperature is, because the gauge on the dash, can you trust that? I don't know. Okay, next I want to check this 4-wire coolant temperature sensor, and on the OE diagram it's this right here, F76 electronic thermo switch multifunction temp sensor. Fancy stuff. So 4 pins. 1 pin comes from ignition fuse, 12-15 amp, black and blue wire, so easy to check. I just have the connector unplugged, and sure enough we have 12 volts on there. So that's 1 out of 4 pins. Now the other 3 pins, there's a blue and yellow wire coming from track 276. So you have to pull up like 10 windows here. Track 276, blue and yellow, comes from the instrument cluster, the fancy instrument cluster. Okay, so we don't know what that is, but according to this diagram, it also splices to the engine coolant low level switch, and that is just a switch to ground. So when that wire is grounded, apparently some low coolant warning light should come on. Now we have 2 more wires, blue and green, brown and yellow. They go to 273, 473, and 43. You see how time consuming this is? 273 is right there. So the brown and yellow wire comes from the gauge. Okay, so there should be some kind of high voltage on there, because the gauge is fed, you know, power, and whenever it's grounded through the sensor, depending on the coolant temp sensor, the needle should move. So the brown and yellow wire, let's put a voltmeter on that and see if we can get this needle to move. Alright, so open circuit on that brown and yellow wire coming from the needle, we have 10 volts. That's reasonable. The needle is definitely down. Well, see, it's not all the way on C, it just stays there. And we ground out that wire through a test light, 2.5 volts. And you can see the test light's pretty dim, so that it's carrying a little bit of current. And our gauge did not move whatsoever. Okay. Dang. Let's measure the voltage on the last wire. I assume that's the one going to the engine computer. Oh, where were we here? Okay. So brown and yellow goes to the gauge. Black and green, that's the last one, goes to pins or tracks 43 and 473. Let me look those up. We can measure the voltage on it right now. Alright, so I have the sensor plugged in now. I'm just back probing it right there. And the two circuits I'm really interested in is the ECU circuit and then the gauge circuit. So first, with the key off, I want to measure the resistance between those wires and ground. So this sensor has to ground these wires because there is no dedicated ground on any one of these. There's battery positive. There's this wire from the cluster that gets grounded with the low level switch, so that's has to be a positive voltage mode, unless the coolant level is low. This one's coming from the gauge, it's 10 volts. This one's coming from the ECU, 9.5 volts, again unplugged. Plugged in, well, first let's check the resistances. So on the brown and yellow, the resistance is 212 ohms. On the blue and green, about 3.5 kiloohms. Okay, that's reasonable. Well, let's turn. Alright, so unplugged, this is our gauge, 10 volts. This is our ECU, 9.5. Plugged in, that goes to 9.4, this goes to 9.5. Let's start up the car, see if these numbers drop while the car's warming up. Alright, so from a cold start, this is the gauge, started at 9.5. It's dropping, but we know the gauge on the cluster doesn't work. The circuit's good though. ECU circuit, 9.6 volts, holding steady. I don't know what to make of that. Okay, so now the top of the radiator is at 92 C. We're approaching boiling point of water. We're at 6.5 volts on the gauge side. Computer side has not changed. Lower hose, about 85 C. And you can see the entire radiator is hot, so there's good flow. We're almost at boiling, 97 C. The fan has to kick on sooner or later, I hope. Woohoo! Just kicked on. Dropping temperature here. Yes, that's the second stage. Down. Picked off on its own. So let's do one more cycle. So about 6 volts now. See that voltage raised up. We'll wait for it to heat up again and cycle the fan one more time. Alright, here we go again. So at 5.8 on the gauge, this thing kicks on. And on our thermal camera, yep, we're pulled right down. See, that's timing pretty quickly. Alright, so this car is not going to overheat. At least the thermal switch works on the radiator. But it's got other issues. So that was about 2 hours, well, probably 3 hours, including the wiring diagram research for the owner. And well, we definitely got good data. But can we say, hey, your thermal switch is still bad for the computer side? Does that matter? With no live data, you can see how difficult and time consuming it is to troubleshoot these computerized early cars where you can't plug in a scanner. So we'll see what the owner wants to do. Obviously his gauge in the cluster doesn't work. that's a cluster problem. We see the voltages are fine. Yeah, it's a bummer. So you won't know what his engine temperature is. Turbo coolant pump control unit. Here it is. It's under the dash. It's not. It looks like it could be a relay. It's not. It is a whole bunch of components. I guess it's solid state. And we have some major green crusties, so it might be a burn mark right here. I'm going to try to clean this up because this is not turning on our fan on low stage, and well, it's not doing what it should. Alright, so looks like good news here. So cleaning up this turbo after pump fan delay controller seems to have worked. So right now it's installed. So with the key on, you can see the test light I have installed in place of the coolant pump because we can't hear it with the fan on. Just want to make sure that circuit's energized when it's supposed to be. So you can see it came on, turned off. That's normal. Key on, it checks. Basically runs the coolant pump for like 3 seconds. All right. So now, when is this after fan delay supposed to come on? Well, when you shut the engine off, if it's really hot, if that coolant or turbo, thermo sensor is closed, it wants to keep running this auxiliary pump and the fan to cool everything down while the car's off. So let's simulate that. Right now the car's cooled down, but if we turn the key off, and send 12 volts through a test light, you'll see my voltage here, to that thermo switch. When that thermo switch is closed. So that works. The fan works on medium and high speed. That's good. I was worried about the computer circuit on the 4-pin, multifunction temperature sensor, but on the OE diagrams, there's another coolant sensor that goes to the computer, and that's this one right here, 2-wire, brown and whatever, gray and brown, and the other one's a ground wire. So I'm not worried about that one. I think that one might be a safety, whatever. If that one fails, and they'll use this one. It's either on or off. That's why we didn't see the voltage change. It was always at 9.5. So I think we're in pretty good shape. The last thing that I found was a really nasty looking corroded fuse that fed the turbo coolant pump, and whenever I wiggled it in the box it would basically be intermittent. So I just put a new fuse in here, and that should solve our fan problems. So clean the relay, replace a fuse, no parts required, but the gauge on the cluster is just stuck. Maybe we can manually try to move that needle around. I don't know. See if it comes back to life. I think we're in pretty good shape. So before taking this thing on the road, I just want to make sure that it has old tires. So if I have a blowout, I want to make sure the jack and the spare tire are ready to go. That was supposed to happen. Uh-oh. Some of the plastic might have gotten maybe it's old grease. hope it's not just threaded into the plastic there. Well, I guess it works. Seems to work like a charm now. There we go. Wheels off the ground. Sweet.